Hello, everyone. In this video, I will explain the sections of a simplified log file. At the conclusion of this video, you'll be able to quickly find needed information to assist in ensuring that your design is meeting the desired requirements. The simplified log files update at the conclusion of each phase of your synthesis run. Let's begin by opening the simplified log file. This is accomplished by highlighting the intended implementation and clicking the View Log button located on the left side of the Simplify GUI. Once open, you would notice that the log file is separated into two sections, synthesis and place and route. Place and route section of the log file only appears if you choose to run the vendor place and route tool from within Synplify. In the first section of the log file, you can check the Synplify package that was being used for the synthesis run and the version of Synplify that is being used. Once you expand the synthesis tab on the left-hand side, notice that the log file sections are separated by the phases of a synthesis run. Compiler report highlights important notes, warnings, and errors that occur during the compilation of your design. In the compiler constraint applicator section, a key piece of information that you will see in the design is the design groups that your design is split into when distributed compilation is utilized. For each group, you will not only see the compilation status, but also the modules that are part of those groups and the runtime for each group as well. Upon clicking the pre-mapping report section, you immediately see the important notes, warnings, and errors that your design experiences during the pre-map phase. Let's now look at the two subsections for the pre-mapping report, clock summary and clock conversion. Clock summary highlights the clocks that are in your design and immediately shows you whether those clocks are constrained in the FDC file. In this particular log file, you notice two clocks that are displayed. For these clocks, you see the requested frequency and requested period, which are constraints set in the FDC file. Under clock type, you also see the word declared. This shows that the clocks were indeed constrained in the FDC file. If these clocks were unconstrained, then you will see the word inferred instead. If the clocks were unconstrained, but derived from a clock that is constrained, then you will see the word derived here. Examples of derived clocks are resulting clocks from PLLs and clock dividers. In the section below, you should see clock load summary, which highlights the source pin for each clock and the number of sequential loads that each clock is driving. Let's now go back to the left of the screen and click clock conversion. This section highlights the number of sequential elements that both gated and non-gated clocks are driving, along with the driving element for the clock itself, which can include a port, data structure, PLL, and also other elements. Let's now look at the mapper section of the log file. You would notice any important notes, warnings, and errors that take place during the mapping phase in this section. If distributed synthesis is utilized, this section also displays the number of synthesis groups that the design is split into, and also the number of parallel processes that were set to run the group simultaneously. Also, notice the runtime is displayed for each individual group. Let's take a look at the timing report. Looking at the performance summary, not only highlights the requested clock constraints, but also the estimated max frequencies for each clock. The clock relationship section displays the relationship between each clock in the design. The interface information section allows you to see the needed information for the worst slack for the clocks in your design. The sections of the detailed report of clocks highlight important notes, warnings, errors, and clock information such as slack, but in a format that is specific to each clock in your design. Resource utilization displays the resources that are utilized for the cells and primitives that are available for the specific part that your design is targeting. This section also displays the number of global clock buffers that are being utilized in comparison to the clock buffers that are available for the part that is being used by your design as well. If you ran place and route by using the FPGA vendor tool from within Synplify, then the log file also includes a place and route session, which has the vendor place and route report. By clicking Control F and typing design timing summary, you're able to see the final timing report, which includes the worst negative slack for your design and also the associated timing numbers. In the clock summary section below, you're also able to see the clock constraints that propagated from the simplified FDC file to the place and route vendor's constraint file. This marks the end of the simplified log file tutorial. Thank you for watching, and we will see you in the next one.